Today's talk is Beyond Security, Getting to Know OpenBSD's Real Purpose. She did a great job introducing me, so I'm just going to jump right into it. I've been a BSD user since 1986, back in college, and a sysadmin since 1995. There it goes. And I've been working with the FreeBSD and OpenBSD communities since 2000 or so, getting more and more involved with the BSD family. But today is all OpenBSD. So, what is OpenBSD? Why should anybody care? Oh, and before I go too far, I did want to say, usually I ask for questions at any time during the talk. I'm going to be only taking questions at the end of this talk because we're not all in one room and it's hard to have a real dynamic conversation like you can at a user group meeting. But I will go through all the questions. So, OpenBSD. OpenBSD is a free Unix-like operating system. If you read their web page, they say that they emphasize portability, standardization, correctness, proactive security, and integrated cryptography. It's built on traditional BSD Unix, which goes back decades, and is actually a direct descendant of the original AT&T Unix. OpenBSD doesn't use the word Unix because Unix is a trademark, and your operating system must be certified before it can use that word. But it's Unix in all but trademark. So, some things that make OpenBSD special is their fully open licensing. They are very firmly committed to freely reusable code, and we'll touch on all of these through the talk. They're very bent on the idea of doing things correctly or not doing them at all. If they can't do something well, they don't. Another thing that may be a surprise is that OpenBSD is written for the developers, by the developers. They're not really trying to attract market share, but really they see OpenBSD as a pressure cooker for improving the internet and the world. So, by fully open licensing, what they mean is that you need to keep their copyright notice and their disclaimer in the code. And you're free to use this for anything. You can share it with other people. You don't have to. And they have a disclaimer of responsibility so that if the code doesn't work in the way that you think it should, nobody's going to come back and sue the OpenBSD folks. You can take OpenBSD, you can embed it in products, you can use it to provide service, you can resell it to customers, you can do anything you want with it. The licensing can be a contentious subject, so I wanted to touch on it very briefly. The BSD license is very different from the GNU General Public License. The idea behind the GPL is great. The whole idea of share and share alike is something we really try to instill in our children and in our community, that we should share with one another. And I think that's just grand, especially with something like source code where it really costs nothing to share. The BSD license has a different goal. It's a gift to the world. The idea with BSD is that you are raising the standard for the minimal acceptable quality of source code. if you can't do a TCP/IP stack that is better than OpenBSD's, why write one? Just use the BSD stack. And why is this important? Well, if you think back, say, in the mid-90s when everybody was trying to wedge the Internet into their computer products, imagine what would have happened if Microsoft had written their own IP stack, or if Novell had, or if any of these vendors had tried to do everything on their own from nothing. It would have been a worse disaster than it was already. So OpenBSD has extensively audited their source code and their protocols for compliance to the BSD license. And as far as licensing goes, licensing also applies to the protocols that they use. Years ago, Cisco came up with a virtual router redundancy protocol so that routers could fail over. And they said that people could deploy this protocol under what's called a reasonable and non-discriminatory terms, meaning you can deploy it so long as you promise not to sue Cisco. This is extra licensing above what the BSD license permits. There's nothing in the BSD license about you can't use this code to sue Cisco. So the OpenBSD folks went and developed their own router redundancy protocol called CARP, the Common Address Redundancy Protocol. This included a lot of features that were not in Cisco's VERP at the time. And there have been a lot of arguments over the years of should they or shouldn't they have done this. I was one of the first people who deployed CARP, and I already had a VERP cluster going. And what I found was that at the time, deploying CARP on a network that already had VERP running confused the Cisco routers. And I wound up filing bug reports with Cisco because if they received a packet that looked something like VERP but wasn't, they would fail. And Cisco improved VERP partially as a result of this, and today I would say their VERP stack is much more robust than it was back then. But the end result of all of this turned out to be that for certain products, Cisco now supports CARP as well as VERP. So, operating systems take the blame. The OpenBSD focus on do it right or don't do it is partially comes out of the fact that they accept that you're going to blame the operating system. If your application fails and you lose data on the disk, people will blame the operating system. So, this extends into a couple key features on how OpenBSD supports binary drivers and how they interact with non-disclosure agreements. Binary drivers. Some vendors to this day provide binary drivers for their hardware, such as video cards or network cards. These binary drivers, usually for Linux, get loaded into the kernel. When you have something running in the kernel, there's really no way to prevent it from accessing things it shouldn't. There's no way to audit this code to see if it's really doing what it says. If you're running in the kernel, a video driver could capture all data being written to the disk and send it to the vendor. there's no way to really prevent this kind of behavior or any other kind of behavior that the binary author would want to do. This binary could interfere with file systems. It could do anything. So the OpenBSD folks say no, they will not take binary-only drivers. They welcome vendors to provide them documentation so they can write device drivers. They adore vendors who say, here's some documentation and a device driver under a BSD license. Please include this. Now, they'll probably audit that driver and make sure it works and provide additional Q&A for that vendor, but everybody wins in this case. But binary drivers are just unacceptable. And a similar thing on non-disclosure agreements. Many vendors will only provide documentation on their hardware under a non-disclosure agreement. Many years ago, Sun Microsystems did this with their, I believe it was the Spark 3 chip. OpenBSD would not support that hardware because even if a OpenBSD developer signed the NDA and wrote the driver, how could anybody check their work? How could other people support the driver? Non-disclosure agreements mean that a driver is essentially black magic. Nobody who has not signed the NDA knows how it's supposed to work. This means it's unsupportable in the long run, and so that's unacceptable. So, from the outside, looking in, you might see that OpenBSD has a few problems. The fact that they do what they do can be perceived as a bug. They don't port arbitrary file systems to OpenBSD. They're not interested in that. That's not going to happen. If OpenBSD doesn't meet your needs, they're not really terribly concerned. And of course, if you look at their presentations, all of the OpenBSD folks have this really kind of disturbing preference for Comic Sans. So, on their target users, OpenBSD is written for the developers. If you can use it, though, that's great. They're happy to see that people do use their code and do use what they work so hard on. This is why they make it public, so that you can use it. If you're not skilled enough to use it, though, if you don't know how to read a man page, if you're not capable of debugging problems on your own, that's okay. It doesn't make you a bad person, but you really need to go use something else. They're not going to hold your hand. If you need features that aren't in OpenBSD, you can either use something else or write the features. They are actively interested in people joining their community and doing things the right, the secure way. So, OpenBSD is more than just security. They use their position to try to shift how the entire internet works. This is the pressure cooker element. They don't go and write entire new features and just drop them in the operating system. They start off small and improve from there. One of the earliest examples of this is when they worked with ProPolice and memory stack randomization. Even back in the 1990s, we knew that having information stored in memory on a live system in a predictable, deterministic order was not really good. Compilers supported options to randomize the memory stack. But if you turned it on, lots of software would break. A lot of hardware supported features like write or execute. Not the i386, but I believe PowerPC did and Spark did. So OpenBSD guys, they looked at this and they said, the memory randomization is a really good idea. This will ensure security for a lot of applications. Nothing ensures total security, but this is the obvious next step that will really help. So in 2002, they turned on memory randomization and stuff broke. Stuff like software that had bugs. There was software that had buffer overflows, and it used the buffer overflows to do their job, not because the author intended it that way, but that's how the code worked out. And similarly, there was software that worked for the wrong reason. I know I've written Perl and Shell for specific sysadmin tasks and gone back to look at it later and been unable to figure out why it worked at all. And in debugging it, discovered that the code didn't do what I actually thought. And this happens to everyone. So, if you're a lone person and you enable memory stack randomization on your computer and you file a bug report with a piece of software saying that I turn on memory randomization and you break, the software author is probably going to say, don't turn on memory randomization, that breaks everything. If, however, you start getting reports that your software is broken on an entire operating system for all users, you treat those bug reports differently. So OpenBSD has thousands and thousands of users. It's a sufficiently large user base that they're hard to ignore. And when you get bug reports on that scale, you look at them and maybe you find out that your software didn't work the way you expected. Thousands of software packages got bugs fixed because OpenBSD took this step. Were those bugs exploitable? I don't know. Nobody really knows. But I'm sure that some of them were. And the end result of this is by eliminating those bugs in all of these packages, we improved the security of the entire world. This also paved the way for other operating systems to enable these features. So today you have memory randomization across the vast majority of the operating system world. FreeBSD is looking at deploying it in the very near future. And even Microsoft Windows randomizes their memory stack by default today. Someone had to be the first, and the OpenBSD guys took it on the chin. So, let's talk about something that everybody on this call uses, OpenSSH. SSH was originally written by one man to meet his needs, but he put it out on the internet and it quickly gained adoption and acceptance. So he went and started a company to commercialize his software, which is fine. The problem is everybody needs SSH. Telnet usually sends data across the internet unencrypted. Anyone could capture it. This was not really suitable for the internet as a whole in the 21st century. So the OpenBSD guys happened to notice that SSH 1.2.12 had a permissive BSD style license. They started with that. They did a lot of work to bring that code up to modern standards where it could do what people expected it to do today. They branded it as OpenSSH. And today, OpenSSH has over 90% share of the SSH market. Everybody uses it unless they have specific reasons not to. Today, there's no reason to send unencrypted data transfers across the internet, thanks to OpenSSH. Now, OpenSSH is developed inside OpenBSD. New features hit there first, and then they're bundled up as portable OpenSSH and sent elsewhere. And this is something else that changed the internet. Privilege separation. A lot of processes need to run as root. Usually this is because they bind to what's called a privilege port, a TCP or UDP port numbered 1024 or less. The problem is that many of these pieces of software only need root privileges for that binding and not for anything else. This is how a lot of machines got broken into. If your web server runs as root and you break into it, if your web server runs as root and someone else breaks into it, they have root on your machine. Privilege separation is a technique for having one process run specifically as root that just binds to the port. It then drops privilege and runs as an unprivileged user for everything else. OpenSSH does this. In OpenBSD, everything does it, even if there's no way that anybody can see that a program could be used to exploit the system. They use privilege separation. Even ping, traceroute, these basic programs. I don't know how someone could exploit them, but OpenBSD assumes that there's a lot of clever people out there. Privilege separation is more widespread now than it used to be. People other than OpenBSD do use it, but this one really didn't change anything in the world as a whole. Then we have things like strcpy and strcat. I'm not a programmer, so I can't say exactly how much better these are to use, but these safer string functions changed the way buffer overflows were handled by the operating system. Are these slides being pushed? Yes, okay. The string functions, strcpy and strcat, were responsible for a lot of security problems. These safer versions were first created in the OpenBSD world. They quickly gained popularity and were picked up by OS X, other BSDs, the Linux kernel, Solaris, etc. They're not in glibc, but many software packages carry versions of them. Packages like glib2, PostgreSQL, MySQL, bind, ISC, DHCPD, LLVM. These APIs changed the security of the C language across the world. And OpenBSD does this over and over again. Their general idea is, this is a good idea, we will take the plunge. They see Spark Stack Go, stack protection, initial sequence number randomization. They recently took the plunge on a 64-bit time T, which should outlast the life of the universe. They have a bunch of other nifty features that are not really meant to stretch the world, but 30-some hardware platforms let them catch bugs that many others can't. They have a very sophisticated but simple packet filter. They've created things like the tmux window multiplier, which is much like the GNU screen, but I personally find it much easier and simpler to use. Their swap space is automatically encrypted in small pieces, each with its own key that gets thrown away when that memory is rotated out. OpenBGPD, OpenOSPFD, these were the first guys to integrate IPv6, and so on and so on. So, let's talk a little bit about what's been in the news lately. LibreSSL. OpenSSL is the most widely deployed SSL security suite. And like any piece of software, it has bugs. The heartbeat bug that hit the news lately is just another bug. It does happen. We kind of have to live with these things. But there are other things that are more concerning about OpenSSL. It runs on everything, including 16-bit Windows systems, VMS, and platforms that really most people don't have to worry about. This means that OpenSSL has to assume that the underlying operating system has nothing, and so it must supply everything, including malloc. So, OpenSSL asks the operating system for memory, and it hangs on to that memory until OpenSSL exits. This means that even automated code scanning tools like Valgrind and Coverity that check for memory allocation problems don't see any, because the program asked for memory, it asked for more memory, it asked for more memory, and then it let it all go and exit. This is fine. But inside OpenSSL, it would ask for memory from the allocated pool. It would then free memory back to this pool. And this is a classic security problem. If you disable OpenSSL's malloc layer, a couple things happen. All of these code analysis tools light up screaming, and OpenSSL stops working. This is a problem. Not only is this malloc layer used, it is mandatory. So, this means that OpenSSL is going to have problems until someone sucks it up and tries to fix it. LibreSSL is a fork of OpenSSL. Their goals are to preserve ABI and API compatibility as much as humanly possible. They want to bring more people into working on the code by making the code more readable. They want to use modern coding practices. Code has changed a bit since the days of 16-bit Windows. And today's programmers are often totally unfamiliar with how code was written 20 years ago. They also intend to do OpenSSH-style portability. So, what exactly does that mean? The OpenSSH portability means that they assume a specific operating system with specific features. In their case, OpenBSD, and they code to that standard. They build and maintain the code on that platform. They provide portability shims to do things that other OSs don't provide, and only for those that need it. They assume that your operating system will provide malloc, that it can provide entropy, and if it can't provide those things, it just won't run. They don't use a whole bunch of if-defs. They don't compromise on functions. For example, there's a difference between B0 and B0 explicit. You have to have the proper functions or they'll provide a substitute that works. And they specifically refuse to re-implement libc. OpenSSL does things differently. They assume that the target operating system provides nothing, so they have to re-implement it all. They scatter if-def and if-ndef everywhere. This makes the logic hard to follow. It's written in many different styles from many different people from many different cultures. And for debugging, they let you set a bit, and this will dump the contents of the entire memory to a file, which is certainly not optimal. So, how do they take OpenSSL and fork it? First thing they did is they dropped non-modern platforms. Windows 16-bit, VMS. There are people who are running these, and they're going to have to stay with OpenSSL. They dropped the built-in FIPS compliance stuff. It's very intrusive. People can still get their sites FIPS certified without this code being in LibreSSL. They assume that the operating system provides entropy. OpenSSL used things like the entropy gathering daemon, your RSA private key, hard-coded strings that would say, here's a seed for entropy, and old things that have long been shown to be poor practice like get PID or get time of day. They've also pillaged the OpenSSL bug tracker. The Heartbleed bug was in OpenSSL for a long time before. I'm sorry, I misspeak. It was not the Heartbleed bug. There are problems with the malloc replacement layer that were in the OpenSSL bug tracker for several years where nobody acted on them. So they're taking advantage of bugs that of bug reports that other people submitted for OpenSSL. And then there are some things they've just done as sweeping changes. They've converted to a single code style. There are calls to malloc and mset that they use the calloc system call for. There are well-known problems with malloc x times y that they just replaced with realloc. They're very sensitive on this. If you go to the OpenBSD main web page, it says there are 2 security holes in a very long time, and one of them was a malloc x times y call. Realloc and free handle null, so they don't test for that the way that OpenSSL does. So that's all easy grunt work. Then there's the hard stuff. Why does this code do this? Should the code do this? Does it adhere to the spec? Does it work? These are all the hard things. And then there are things like, should we reduce the API? OpenSSL exposes the entire API, both the internal stuff and the external stuff. And it's hard to know what really should be in that, what should be exposed, and what shouldn't. That will probably change, but only slowly over time. Some things on portability. A lot of people have said they've ported OpenSSL, or they've ported LibreSSL, but usually they take shortcuts. The B0 function is supposed to zero out memory. Frequently, a compiler will optimize that away. You can't just replace the explicit B0 with B0 calls and call it ported. Similarly, arc4 random is not truly random. You can't just replace strlcat calls for strcat calls, etc. The OpenBSD guys want a LibreSSL portability team that understands what each platform provides and what they need to provide. That's exactly what they do for OpenSSH. So, I'm going to touch on here one of the parts that nobody really likes to talk about, and that's money. For years, OpenBSD has been supported by sales of OpenBSD CD sets, T-shirts, and books. As you might guess, the CD sale business has tanked, and it has tanked increasingly more. They do sell a lot of things to try to raise money. They have several of my books that you can buy from the OpenBSD bookstore, and the proceeds go to support the project. Another thing that they do is they set up the OpenBSD Foundation to take donations. They really want LibreSSL to succeed, but they're not willing to let OpenBSD or OpenSSH fail so that LibreSSL succeeds. If your organization is using OpenBSD, OpenSSH, or wants to see LibreSSL succeed, I would really encourage you to go to the OpenBSD Foundation website and send them a few bucks. And the truth is, LibreSSL is just the current problem. Something's going to be discovered, if not tomorrow, the next day, or the next year, that needs a group of people who can take on this kind of problem. And I want these guys to continue to exist just so they can keep doing what it is that they do.